In this lesson, 2.1, we're talking about basic polynomial operations. The learning target is that we're going to be able to add, subtract, and multiply polynomials. But before we get to that point, I want to talk to you about how to name or classify a polynomial. So it may be helpful to know what examples are not polynomials. All right, so things that have negative exponents, things that have a radical over a variable. It's okay to have a radical with a number, but things that have a radical over a variable would give you a radical function. Things that are set up like this where you have a fraction, then that's a rational function. So these are non-examples, all right? But then these are examples that are polynomials. And we name a polynomial with two things. Number one, we name it with the number of terms, and we do it with the degree. Now, a degree is basically just the exponent. So if the largest exponent is a 5, then we would name it with a degree of 5. All right, and then the number of terms would be, how many terms are there? There are 1, 2, 3, 4, 5, 6, 7 terms. All right, now every single one of these are considered polynomials. However, if there's only 1 term, 2 terms, or 3 terms, they're given more specific names. All right, so you would want to use the most specific name. Would it be okay to call it a polynomial? Yes, but you would want to be the most specific that you could be. All right, so if we look at some of these examples up here, this has a degree of 4 because that's the highest exponent, and then it has 1 term. So the term being 1 term makes it a monomial, but the fact that the degree is 4 makes it a quartic function. So we would call this a quartic monomial. All right, another example, if we look down here, this one right here, the highest degree is 3. That makes it a cubic function, but there's 3 terms, so that makes it a cubic trinomial. All right, and then this example has 4 terms and a degree of 4. So this makes it a quartic polynomial because there's 4 terms. Okay, so using this chart right here, I want you to fill in the chart that's on the bottom of your paper. So I'm going to give you some time and then I'm going to reveal the answers. So I want you to press pause on the video so that you can try those yourself first and then come back to it. All right, hopefully you pressed pause and tried those on your own. All right, but these are the answers that you should have gotten. All right, so I'll give you a moment to check your work, pause the video again, check your answers. All right, so what we've just done is basically just named our polynomials. All right, so that if I call something in a video, hey, look at this, cubic binomial, then you know what I'm talking about. All right, so on the next page of your packet, all right, there are several problems, okay, and I'm going to do just the ones that I kind of have highlighted just so that you have some examples. All right, so the first example that I'm going to do, I'm on page 5, is example 4. All right, this is a tough one. This has a mixture of multiplication, subtraction, addition. It's got a little bit of everything. All right, so think about your order of operations. Please excuse my dear Aunt Sally. The first thing we would do is distribute, okay? So we don't have anything in our parentheses that can combine, so we're going to go ahead and distribute anything that can be distributed. All right, so in this first term, we would have negative 6x and then negative 4y. The second one, you're distributing a negative, so that's almost like having a negative 1 there, and for some people it may be helpful to put a 1 there, just so that they kind of remember that it is a negative 1. So negative 1 times 5x is minus 5x, and then a negative times a negative makes that a positive 6y, and then we still have plus 2x minus 7. Now we need to combine our like terms. All right, so I'm going to go ahead and start with my x's first, and then I'll go to my y's, and then I'm going to go to my numbers or my constants. All right, so for my x's, I have a negative 6x and a negative 5x and a positive 2x. So negative 6 and negative 5 give me negative 11, plus 2 gives me a negative 9 x. Then I'm going to go to my y's. So I have a negative 4y and a positive 6y. And if I combine those, I get positive 2y. And then the constant by itself, so minus 7. All right, and that's my answer. So when you are putting things in standard form, if you have multiple variables, you typically go in alphabetical order, okay? And if you have the same variables but different exponents, then you go in order from the largest exponent and you trickle down to the smallest exponent. So let's take a look at number 6. All right, so with number 6, we have an addition problem. The largest degree, though, is a 3, and there's different numbers of terms, and that's okay. So I'm just going to go in order from my largest exponent, and I'm going to trickle all the way down. All right, so I'm going to combine 2x cubed and 5x cubed to get 7x cubed. Now I want to go in order, so I'm going to go over here to the square term because I want to go from largest exponent and trickle down. Well, there's nothing to combine with that, so it's just minus 9x squared. It just drops down. Now I'm going to go to my x's, so I have 5x and I have negative 11x. Well, that makes minus 6x, and then my constants, a negative 8 and a positive 5 make a minus 3. So if you combine them in order, then you'll naturally be putting it in standard form. So not only do you need to combine like terms, but you also need to make sure that they're in order. Largest exponent all the way down to the constant, okay? Another example is with multiplication. So with multiplication, there's some different methods. I prefer to distribute. So I'm going to take my first term and distribute it to both of my second parenthesis terms. So x times x is x squared. X times 5 is a positive 5x. Now I'm going to switch gears and I'm going to distribute the 3. So 3 gets distributed to both of those terms. So I end up with a positive 3x, and 3 times 5 is 15. The last thing you want to do is combine your like terms, which are these two in the middle. So when I combine those, I end up with x squared plus 8x plus 15. Okay. Now number 8 is actually just like that. It just looks a little different. So think about squaring. If you square something, if I say, what is 5 squared? You would say 5 times 5 is 25, right? Well, the same thing goes here. If you have a polynomial, or in this case a binomial squared, then you write it twice. 2x minus 5 times 2x minus 5. And now I'm going to distribute. So I'm going to distribute the 2x to both terms to get 4x squared minus 10x. And then I'm going to distribute the negative 5 to both terms to get minus 10x, and then a negative times a negative makes that positive 25. Again, the last thing you want to do is combine your like terms, which are the two middle terms. So we have 4x squared minus 20x plus 25. Another example is when you're distributing and you have variables that have exponents of higher degrees, all right? So what do you do with those? So when you distribute this, negative 6 times 3 is negative 18. But what is y squared times y squared? Well, you're not doing 2 times 2. It's actually 2 plus 2. You add the exponents. So that would give me y to the 4th power minus. All right, well, actually, it's going to be a plus because a negative times a negative makes a positive, 12. But what is y squared times y? Well, that would be y cubed because, remember, we're adding exponents. And then the last part of that, a negative times a negative, gives me a positive with a 42, y squared. And then just double check that you're in order from largest exponent down to smallest exponent, and we are. Another example is when you're multiplying a larger set of terms. All right, so we have a binomial times a trinomial. So I'm going to distribute still, just like I've been distributing, but this time I'm distributing to 3 different terms. So I end up with 2a cubed positive 4a squared minus 8a. And then I need to do the second term, which is a 3, and I'm distributing it. Now, because this is going to be a long string, I'm going to kind of naturally fall under this, but I'm going to make sure I'm kind of lining up my terms. So I have 3a squared. I'm going to line that up with the squares. 6a, positive 6a, right? So I'm lining that up with my a, and then minus 12. All right, so I kind of intentionally lined up so that when I combine my like terms, it makes it a little bit easier. So 2a cubed plus 7a squared minus 2a minus 12. All right, and then it is in standard form. All right. Now we have a much more difficult problem, and this is an example of like maybe if you had a volume problem, and volume is length times width times height. The problem is we can't multiply all 3 of those at the same time. So we're going to have to pick 2 of them and multiply those, and then do a second problem where we bring in this last piece. All right, so I'm going to multiply x minus 2 times x squared plus 4. I'm only going to use those 2. So I'm going to distribute to get x to the 3rd plus 4x, distribute to get negative 2x squared minus 8. It's not in order, so I'm going to go ahead and rewrite this in order. X cubed minus 2x squared plus 4x minus 8. Remember, you want to be in standard form, which is largest exponent all the way down to the smallest and the constant. Now we need to multiply one more problem. We still haven't used this 2x plus 3. So I'm going to say 2x plus 3 times, let me shrink this up a little bit, times the answer that I just got. X cubed minus 2x squared plus 4x minus 8. All right. So now I'm going to multiply that. And there's a lot of terms, but that's okay. All right, so we're going to distribute to 4 terms, all 4 of them. There's a bunch, right? So we have 2x to the 4th power minus 4x cubed plus 8x squared minus 16x. So that's my first term. Now I need to do the same thing, but with the 3. So the 3 is going to get distributed to all 4 of these terms as well. So I end up with 3x cubed. I'm going to intentionally put it with the cube. Negative 6x squared. Positive 12x. And then minus 24. All right. And so I like that they're all lined up. So I'm going to go ahead and just combine my like terms. So 2x to the 4 minus 1x cubed plus 2x squared minus 4x minus 24. All right, and that's it. So that's a lengthy problem in itself. All right, so then sometimes we have perimeter and area. All right, so with this particular problem, we have the first part is asking the perimeter, and then area is as well. All right, so perimeter is where you add up all sides. Well, there's 4 sides. That means if this side is 5x plus 2, this side is 5x plus 2. If this side is 3x plus 8, then this is 3x plus 8. All right, so remember a rectangle, opposite sides are congruent. All right, so when we add up these terms, you can write them all out, or you can kind of combine within your shape. All right, so I'm going to combine within my shape. So I'm going to add all my x's. So I have 3x plus 3x, 5x, and 5x. So what do I get when I add those together? Well, 5 and 5 make 10, and then 3 and 3 make 6. 10 plus 6 is 16x. Then we have the numbers or the constants. We have a positive 2, a positive 8, a positive 8, and a positive 2. So if you add those up, you get a positive 20. Just be real careful with signs there because sometimes they are negatives. All right, so the perimeter of this shape would be 16x plus 20, and then since we don't know the units, we just put units. But if it had been feet, we would have said feet and so on. All right, now area is length times width. So the length is either one of these, it really doesn't matter, right? But we would say 5x plus 2 times the width, which would be 3x plus 8. So we'll distribute to get 15x squared, 40x, 6x, and 16. And then combine your like terms to get 15x squared plus 46x plus 16. And since we don't know the units, then we're going to put units squared or square units. And that is the area of that figure. All right, the last example is just perimeter, but I want to remind you that perimeter is the distance around a figure or a shape. All right, so even though this is here, we don't need that part, okay? So if these also give us congruency markings. Single ticks mean that single ticks are equal to each other or congruent. So if one's 6x minus 4, the other is. And then we have double ticks. Well, that's just trying to tell you that these two sides right here are congruent. So this would also be 12x plus 3. Now, this would be congruent because of the rectangle. However, I don't really need that because it's on the inside of my shape. I really only care about the outside of my shape. All right, so we're going to look at those terms. We're going to look at our x's first. So 6x and 6x, that's 12x. And then 2 more 12x's, so that's 36x. Plus 14x makes 50x. All right, now we need to look at our numbers, and this is where negatives are important, so be careful with your signs. So you have -4 and -4, that makes -8. Positive 3's, so those are -8 and 6 makes -2. Plus 13 makes a positive 11. So be careful again with your signs. All right, so 50x plus 11, we don't know our units, and perimeter is just plain units, not square. All right, so if you have trouble remembering that, perimeter is like if you just measure length. All right, that's one dimensional, so you don't need like squares or cubes or anything like that. All right, if you have area, that's length times width, that's 2-dimensional, and that's why you use square units. If you had volume, that's length times width times height, that's 3-dimensional, and that's why you would use cubic units. All right, so your assignment is to finish the examples or problems that I did not do on page 5, as well as the practice problems on page 6.